Victoria Emerton, and today I'm delighted to be joined by Richard Beckett, Global OEM Relationship Director at Global Water Solutions. Global Water Solutions will be exhibiting at Healthcare Estates on stand F34 on the 21st and the 22nd of October. Richard, thanks very much for joining me and welcome to this podcast.
Thank you, Victoria. It's a pleasure to be here.
So what is a significant engineering challenge in water supply systems for healthcare settings? What are you seeing that's challenging folk in the healthcare sector?
Okay, so that's a great question. There's not so much an engineering challenge for hot water supply to healthcare settings. It's actually, in my opinion, it's the actual thermal expansion tank which goes next to the hot water clarifier. So basically, what you have in hot water supplies is a tank which is full of hot water, and then next to it you have a ubiquitous expansion vessel which has to be connected to look after the pressures which are associated with the temperature gradient and rises in temperature associated with the hot water. So basically, the engineering challenge is to somehow make sure that the water that's within the thermal expansion tank is clean and pure and healthy and does not act as a dead leg for Legionella colonization.
It does sound potentially like one giant petri dish, doesn't it? So how does this technology work?
So basically, if I go back one step, the problem that we have at the moment in the UK, and to be fair, in many parts of the world, is that the engineering principles associated with hot water supply in not just healthcare, but also in most commercial premises, is extremely dated. It goes back decades. And it has not, and the engineering specifications have not kept up with technology. So what we do, what is available now are technologies which will continuously replenish the water that is held within the thermal expansion tank every time that there is a hot water draw off from the hot water calorifier. Now, the engineering principles behind that are rather simple, but the problem is that they're not being specified and they have to be engineered and designed into the specification. So the duty holder of the building, whether it be healthcare, commercial, schools, colleges, hospitals, whatever, understands that there are now products available which will minimize dramatically any possibility of Legionella in the hot water supply procedure.
So Legionella development can be prevented, and it'd be helpful if you can tell us how that's done and what validation methods are in place to make sure that those prevention methods are compliant. You want to be certain that everything's working, don't you?
Okay, another good question. So basically, Legionella is everywhere in fresh water, potentially. We're not going to get rid of it. It's in our drinking water supplies. If you measure for it and test for it, often you'll get Legionella there. It's not a problem whilst it's in potable form or drinking form. The only danger occurs when it is in aerosol form. So when you actually breathe the droplets, the fine droplets of Legionella into your lungs and they settle on your lungs, that's when the problem, and also when the colonization of that Legionella bacteria has, the colonization has grown above a certain level. So the validation of whether a system is appropriate and whether it is clean and pure is done by the water safety group for that particular building or that particular NHS trust or that particular hospital or school, whichever building it is. It's incumbent on the duty holder to and the officers to have a water safety group, and that group has to do the testing, has to do the monitoring, has to do the recording of all of the dangerous water parts within the water supply. So although Legionella cannot be prevented as such, or Legionella pneumophila cannot be prevented as a disease, it can be minimized and it can be managed. And it has to be managed by the local resources within the water safety group and the individuals who are nominated within that group to actually front this type of procedure.
So you've said that Legionella is present everywhere and prevalent in any setting with large hot water supply systems. Is there anything unique to water supply systems in healthcare environments that make them susceptible to Legionella development?
There is very little difference between when you look at the actual mechanics and the engineering water supply. There's very little difference between the healthcare hot water supply and any commercial building hot water supply. They use the same equipment. They use, hot water boilers. They use plate heat exchangers. They use a method of generating hot water, and they use a method of either storing that hot water or giving instantaneous hot water to the patients or to the tenants or whatever. So in essence, there's not a great deal of difference between the principles, the engineering principles associated with healthcare and general commercial. However, when you look at the guidelines and recommendations issued by the HSE, which is HSG 274 Part 2, when we're talking about prevention of Legionella in healthcare premises at HTM 041, then what you have got is a set of overriding recommendations by HSE that must be taken into a factor. And although this is not law, which in my opinion it should be law, but it's not, it's recommendations only by HSE, then I think that I don't think there is any trust anywhere, and there is not any water safety group that would not take into account the recommendations of HSG 274 Part 2. So that in itself is, although there's no great difference, the way that you monitor and manage healthcare is a lot more stringent and a lot more closely observed than many certainly lighter commercial and certainly domestic applications.
I guess the population of healthcare settings is quite unique as well, isn't it? In that the people using those systems are vulnerable from a physiological point of view. They're maybe elderly, they're possibly ill, their immune systems are compromised. So that might feed into the duty of care maybe being amplified within healthcare, would you say?
Well, I would say that, and this is you've hit the nail on the head, which is, why is this not law? I mean, we know that Legionella pneumophila is a killer. 10% of people who catch Legionella will die. And that's what's happening as we sit here and talk about this in our little glass offices here. That's what's happening in the real. Why is this not law? I don't know, but it should be law. And the HSE really should, and it should be government policy to actually implement this. It's not difficult to implement. It's It's highly controlled and highly regulated recommendations. It's not a great step to implement that as in the plumbing and you know, the water supply authority regulations. It should be mandatory. So I agree with you that and a lot of these water supply systems are being applied into immunosuppressed patients, and that is not good. You know, we should not be allowing that in first world countries.
Indeed, and all things that can be discussed at healthcare estates. That's the beauty of getting a lot of folk with the same vested interest to provide excellent quality healthcare and the best run facilities that can be achieved. So really good that we've got Global Water Solutions coming. You're going to be on stand F34 at the event, as I said. So anyone can come along and talk to you. IHE have a technical platform related to water quality, so the IHE Members Lounge is available to people to go along and talk to them too. So thank you so much for your time today, Richard. It's been really interested in talking to you. Healthcare Estates is not far off, so looking forward to seeing you there. So that's it for this episode. Just to remind everybody that the conference programme for the conference and the exhibition theatres is live, as is registration on the Healthcare Estates website, which is www.healthcare-estates.com. Thank you again, Richard, for your time today, and we'll see everyone on the next podcast.
Thank you, Victoria. It's been a pleasure.